NG one the recorder.
Problem number 2. Ready this.
First level challenge.
Okay, please. Put on the record your name. Okay.
Hello everyone. I'm Ming from MD Fresh, and today our topic will be problem 2 related. Problem statement. A disc suspended vertically by a thin thread is placed in an acoustic field. And this device can use to measure the intensity of sound by turning about the axis of the thread and investigate the accuracy of such a device. So our main focus will be loudness and angle, and the relationship between radius and angle. And third, definition of accuracy, as intensity of sound has to correspond to an angle. This is a demonstration video, and here's the disc. So as you can see, we will turn up the volume of the speaker, and the disc will rotate as the volume goes up. And here's the front view. The phenomenal explanation. Our explanation of how the sound wave affects the disc. So as you can see in the video, the disc will vibrate vibrates back and forth. And the reason for this is because sound wave is rarefaction wave, and this causes the disc vibrates back and forth. So this is the calculating for the force of sound flow and the area of the disc. And so when the disc starts to deflect, the perfect circle turns into an ellipse. So by integrating the moments of all angles, we obtain F equals PdA. And F is the force of sound flow, P is pressure, and A is the area of the disc. And this formula can be derived by the eclipse formula. This is the calculation for the area of the disc. And the relationship between sound intensity and pressure. Because the problem statement mainly focuses on the sound intensity, but we think that it also includes sound pressure, and sound pressure will cause torque. So we'll change the sound pressure, the sound intensity into sound pressure. And this, the sound intensity has something to do with the power. So it isn't the square foot. And this has something to do with, this is the square foot of the sound pressure. And the conversion formula for the decibels and sound pressure. We define X is the dB, and X dB equals 10 log P1 over P0 square foot dB. And this is the derivation we did. And P0 is the minimum sound pressure human can hear, and P1 is the sound pressure we measured. And it will equal to 2 times 5 over a power of minus 5 times 10 over power S over 20. And this is the calculation for tau P and tau theta. And in the end, the disc will stay, it will turn almost 90 degrees and stay in this position, except it will vibrate back and forth. And we think that it's because of tau P and tau theta. In the end, they will equal each other. So this formula is the formula for torque. So tau P equals R F and sin theta. And we can change the F equals to F pressure. So R times F pressure times sin theta equals R times PdA sine. And it will equals into this. And this is the calculation we did. And tau theta is K times theta minus theta 0. So in the end, they will equals each other. This is a calculating for theoretical volume. Tau P equals tau theta, as we mentioned. And this is the calculation. In the end, this is the theoretical volume. our experimental setup. Because we did this experiments in an open area, so we think about if the energy will differ or not. So we try to put the disc as close to the speaker as possible. It's only 2 centimeters apart, so the energy will focus onto the disc instead of going out. And here's the DV meter, and this is the tripod. We hang a metal stick onto to hold the thread down here. And this is a tennis ball. We use this so it has weight to hang the string, the thread. This is the calculation for the torque constant. F equals K over R times sine theta. And this is the sine theta. And we change this into rad. So experiment 1, relation between loudness and angle. The independent variables are the loudness, and the dependent variable are the angle of rotation of the disc. And our hypothesis is the louder the sound, the more energy it carries, and the bigger the weight. Hence, the louder the sound, the more rotation it makes. And these are the control variables. At 60 Hertz, 25 temperature is 25 Celsius, and the radius is 7.5 times 10 over minus 3. And this is the thickness. This is the weight of the disc. And the results for experiment 1. And this is radius 0.75. As you can see, there's this area we can't measure any data, and this one as well. So we think in the front, the reason for the missing data is air particle vibration rate is really slow, and so it is lack of energy. And diverging after bypassing the disc. So yeah, the energy will be diverging out of the acoustic field. So the disc will stay stable instead of turning, so we can't measure any data. And the reason why for missing data in the back of this spherical body is air particle vibrates really fast, and so it has excessive energy and form turbulence behind the disc, so the disc will wobble. And this is the flow characteristic and Reynolds number. We think that the flow has something to do with the Reynolds numbers because there's luminar flow and also turbulence flow. And Reynolds numbers is used to determine whether a flow is a luminar transition or turbulence flow. And this is the range of luminar flow, and this is the transition flow, and also turbulence flow. And since R is positive correlative to U, and U is positive correlative to I, so Reynolds number is positive correlative to I. So there's a range of sound intensity which Reynolds numbers remain in range of luminar flow, allowing disc to rotation. Experiment 2, the relation between loudness and angle again was under different radius of the disc. This is our experiment setup, and this is the dependent variable. And the ratings are 0.75, 1 centimeter, 1.25, and 1.5. And hypothesis is the same as previous. And we also control it at 60 Hertz and 25 degrees. The results for experiments using the radius of 0.75. This one is for 1 centimeter, 1.25 centimeters, and 1.5 centimeters. So according to our definition of accuracy, radius 1.5 is indeed more accurate as every loudness corresponds to an angle because these gaps between the data is the same. And the results for experiments altogether, the larger radius causes larger rotation and indicating a more significant change, giving more more accurate results as we defined it. An experiment there is the effect of thread type on the accuracy of relay disc. This is the polyester thread. This thread is the video you saw. And this is the cotton thread and needle thread. So polyester thread is bigger than, the torque will be bigger than cotton than nylon. So polyester has greater accuracy for future measurements. Conclusion, angle and decibels are positively correlated. Only loudness between 70 to 90 dB can be measured. An unstable sound flow can cause experimental error like turbulence flow or load fronts we can measure. A larger radius causes larger variation, meaning a larger rotation of discs leading to more significant changes. And in trails with larger radius, each decibel corresponds to an angle. So continuous intensity corresponds to an angle. That means it is more accurate. A smaller radius has less arrows, but measurements are discontinuous, which means it is less accurate defined by us. And polyester is the best thread type to maximum accuracy. And that's the end of our presentation. Thank you.
Okay, questions from the opponent.
So thank you for the reporter. Please turn to page 3. And we have a picture that so where's the source of the sound?
Here's the speaker. So there's sound.
And please turn to page 5. Sorry, number 4. From video, we can see that the disc is turning. So, do you did many times of the experiment?
But
Did the disc have a specific direction to turn?
I'll just show you a video.
Does it have a specific direction when you turn on the sound?
And the angle of the disc will become larger and close to 90 degrees.
Okay, this one is page 6. And so this picture is a side view or the top view?
This is, we think that the speaker is right here, and this is a top view.
Thank you. And to turn page 7. And so, what is because the bottom has the two equations, so what is the related to the top one?
This one.
So why do you want to show off the bottom, the two formula?
Or just want to let you know because there's this formula and this can correspond to.
Okay, so do you ever measure the pressure?
The pressure we use this x equals dB and we this formula.
Okay. Hands up.
going to report about problem number 2 of graded disk. And first is the problem statement, and it's that the reporter has mentioned before. And I think the problem statement wants us to do is to measure the intensity of sound and find out the accuracy. And then it's a summary and a comment for the report. Here's my summary and comment. For the first is the observation, then the demonstration video, and the theory. And has a phenomenon, explanation, question about the source of the sound and area of this, and the relationship between sound intensity and area. And that the conversion formula and the calculation for tau p and tau k. And the variable is only about the loudness and the radius. And next is the experiment. This experiment setup discuss about the list of data. I think that's pretty good. And the flow characteristic and Reynolds number. And that is the conclusion, which I mentioned that the audio loudness between 70 to 90 dB can be measured. And the advantage that I want to raise is the complete theoretical analysis and the complete conclusion and fluent oral expression. And my suggestion to the reporter is I think that she could put more experience videos or pictures to prove that her data. And then I think that we also lack of the variables about only two. I think maybe we can discuss about more on the discussion hub. And next is the missed point. And first is theory. I want to discuss about how do you define accuracy and what is the theory condition, and then what is the relationship between sensitivity and accuracy. And then next part is the setup and data. I want to ask about what is the ideal disk, because she has raised about the loudness and the radius, and I want to find out that is there possible to find out the ideal disk that we can in an environment that can be the best rated disk. And then we compare the radius 1.5 to the others. And then this experiment and the parameters. First is the over different thickness of the disk effect. And that is over different frequency of the disk effect. I think these two just I want to raise some more variables about the experiments. And the third is in the open space, how to decrease the influence by surroundings and how to fix the result. But I see the reports that our experiment setup is in the open area, and I think that can be something maybe voice or other thing to disperse this result. And so I think that maybe we can discuss about this. And the next is how will the threat influence the result. And that's all my presentation. Thank you. So first, do you think that there's any other parameters that can affect the result?
We only do the radius one, so have you think of any others?
I think that good first indicate that you mentioned about the thickness of your disk. Wait. And I want to ask how do you measure the thickness?
We measure many papers together, and we divide how many paper we use.
And send out the weight.
The weight is we measure the whole paper and count out how many discs we can cut up.
Great. And maybe we can count the whiteboard. Is that so if we think that your thickness of the disk is 2 times bigger, then do you think that will affect your results?
And I don't think so, because the number for the disc is like 10 over power of -7. So if it turns 2 times, it won't affect the result.
So now Now, if we think that because you said that your thickness is 2.2 and then 45, and so if we think that here's the how about 15 centimeters? Do you think that will affect?
Maybe it will affect, and I think if it is much thicker, it will be.
How to demonstrate what you say?
I think if here's the disc and it becomes much thicker, it will be harder for it to rotate because the disc will, the flow comes over the disc and it becomes thicker. I think the flow will like deviate from the acoustic field instead of bypassing.
So, and I want to raise about the, do you have think about to change the frequency?
Frequency. We actually did that, but there's no theoretical formula or anything. Plus, we observed that when the frequency is like 60 times, if it's like 60 and 120, 180, the disc will deflect, and it's kind of like the turbulence will. There's turbulence flow forming when the frequency is 60.
And I think that the report has mentioned about the turbulence. And how do you observe or measure this?
That is what we suggest. So we think that it is because of the.
So you think that there's a turbulence when your experience was conducted?
Yeah, but it is unstable.
So that's just what you would think about.
Yeah.
And I think your report has and your experiment has said that you control the temperature.
Yeah.
And how do you control the temperature?
We turn on the AC.
Okay. And I want to ask about do you have any thinking about the ideal disc after you change your parameters?
You mean the best this?
Yeah.
I think 1.5 is the best because it is more accurate as we define.
Different. About the 1.5 previous parameters. So just tell me again that why do you think that why is the value is the 1.5?
Because the definition of accuracy is a loudness can correspond to an angle, and as you can see, the gap between each data is the same. So every loudness can correspond to an exact angle.
How many times do you conduct this experiment?
We did this 3 times.
And do you think that when you increase the time that you conduct this experiment, will the value change? Oh, okay. That means that if you do this experiment many times, do you think that the value that you think the value is 1.5? Do you think that value will change as you do more experiments?
I don't think so.
And so you think that it's 1.5 cents?
Yeah.
And is your theory conditioned in an ideal way?
Yes.
And so how will you connect your theory to your experience? Because in reality, that might not be really an ideal way.
Because there's an X in our theory, so we can put the loudness, which means the X, into the theory, and it will turn out as the experiment result. So we can put the data onto the theoretical body.
And I want to ask about that. Wait a second. Could you tell me why the tau P and tau theta is in a different direction?
Because the disc will deflect this way. will turn this into this. So it will become almost 90 degrees. And the degree we measure is here.
So the source of sound is coming from here.
Yeah. So here's the LP, and P is for sound pressure.
So in the beginning, your disc will be like vertical or horizontal.
And it will stay like this position every time.
And your source of sound is coming from here.
Yeah.
So initially, there's already has a theta.
Yes. So we measure the delta theta instead of this one.
Okay, that's nice. And I just want to explain that. So when the sounds come from here to here, and what is the direction that this change? Is here from here or?
We'll turn this way.
So
This.
So could you tell me that why the disc will turn this way?
Because here the sound comes from here, and there's sound pressure posed in the disc.
And I want to suggest more about your experiment setup. I mentioned about that you are in an open area. Do you think that it's possible or necessary to stop the influence from the disturb factor?
I think that if we put the disc close enough to the speaker, the energy won't deviate that fast or affects the results real much.
And how close do you suggest?
We put 2 centimeters.
Do you think that is close enough?
Yes. Or otherwise, the thread will touch the speaker.
And I think that if we take a tube and we put the disc inside, and we have a sound source of sound from here, and in my opinion, that's because that will help us to decrease the disturb of the other surroundings. I think that because the sound of source, when the sound comes out, will be like a sphere. And so, then we can make sure that the energy will, most of the energy can be at this. So do you think that is possible to adapt?
I think this is possible, but there's one problem. Do you think the tube will connect to the speaker?
I think the best way is just stick on
The speaker. But if the volume comes from the speaker, the tube will vibrate as well, so we can possibly see it.
So if we just fix the tube, do you think that will be better?
Maybe.
Okay, so we decrease the vibration of the tube, and that would be an ideal experiment setup.
Yeah.
And thank you.
Thank you.
Okay, summary of the discussion by the opponent.
I discussed with the reporter for more variables, and I think that after this discussion, we have also find out that some ideal experiment setup, and I think that we can increase the disturb factor from the surroundings, and also if we fix the tube, and so we can, and the vibration won't really affect the disc. So I think that, and I think the reporter has failed theory, but I think that if we, after this discussion, I think that we could put more variables in the experiment and find out the best ideal disc. And that's all my summary. Thank you.
Questions from the viewer?
Hi, the viewer from the coordinator and first question will be, I'm curious about the thread that you use, and you have three different materials of your thread, right?
Yes.
And I want to know about what different characteristics about the thread that cause the different great results about your data.
So the main effects of different material of the string is the torque.
So I'm curious about the tension of the thread influence the data.
No.
How about your
I think the tension will affect.
okay. And also, I'm curious about the length of the thread, because you can feel that if the length is larger, it's higher, and also the hits will be unstable, right? Because it will be more sensitive.
But we tie heavy stuff under the string or the thread, so it will be tight. So I don't think it will affect.
I mean, the height of the thread will cause a different, the result of the experiment. Height of the thread.
I think it's only the thread that compared with the this, I think it will slightly bad.
Okay, thank you. And I'm curious about how you just still how you document. I can use the tube to improve your experiment equipment. And I'm curious about do you think your experiment is stable to try right now on your data? Because the open every object is not the best choice to use it.
So we try to put the disc as close to the speaker as possible before the energy deviates from the specific.
And you say you use the AC, right? The air
Yeah,
conditioner.
just for the temperature to control.
Oh, okay. And can you turn to the page 16? So you have said that the reason why that caused the 70-75 parts data at the data is because for the energy loss.
Because the energy, the air particle vibrates, and the energy, yeah, as well.
The next question is about I'm curious about if the thread is vibrating, but if that influence the data.
I don't think so.
How about the thread vibrating?
Vibrating or slightly better.
And thank you. so this time today I'm going to review about the orbital tube relatives. And so the main focus will be how is the volume defined and how do you create control levels and measurements side by your means. And second will be to change the value and record the behavior of the disk. What happens at different frequencies? And the third one will be just the behavior of the disk transfer theoretical considerations. And so let's talk about the summary of the report. So the first one, understanding of the problem, is talk about the sound wave and the verification wave, and so about the disk drivers back and forth. And the second will be the theoretical analysis, and the third one will be the intensity, describe sound pressure, and also the relationship of the intensity and pressure. And the second will be the calculation of the total torque. And about the experimental confirmation is about the first one will be the loudness and the angle. And the amount more sound means more energy, so more wave, and that causes more rotation. And the second will be radius and the angle. Large radius causes larger rotation. And the third one will be type of thread. Polyester is the best thread to measure that I talked about. And let's talk about the pros and cons about the reporter. So first of all, the pros. The first, use speaker to quantify the result, and the second will be the experience to verify the theory regarding about the sound intensity, angular velocity, and Reynolds number of the sound flow, and also the total material of the thread, and also to get to the accuracy of the device. And the cons will be the theoretical consideration. For example, it's the angular velocity and the humidity of the air, because I think that will influence the sound of the sound. And also the moment of inertia and the external factors. And the second will be the level of the investigation on friction, and the last will be the inadequate experiment verification on material of disc and thickness. And the fourth will be the lack of the quantitativity described on the conversion between theory and experiment data. And the last one will be the lack of explaining what caused the accuracy. And the pros and cons of the opponent is he have the close short questions, understanding of the experiment well, and also sufficient use of opposition time, and legitimate questions asked on further understanding of the theory, and also focus on what the reporter said in a good manner. And the last cons will be the lack of comments on the reporters, and I think there's And the second will be the voice is not loud enough, I think. And let's talk about the discussion part. So the first opponent said, do you think that there will be another parameters that will change? And so the person says about the radius, and also the opponent said the thickness of the disc and the frequency of the sound will influence. And I also think the material of the disc or the length will influence of the tube. And the second discussion will be will the value change when you do more times of the experiment? Is the value really accurate? And the first question will be no, and the second will be yes, and I will think that there might be do more experimental data. And the third will be the theory. So let's talk about the recent points. So the first will be the quantitatively describe the distribution of the pressure, and the second will be the regular swinging of the disc, and the third one will be whether the force on the disc is average, I think. And the fourth one is the influence of the air flow because they use the air conditioner. And the fifth will be the friction between the disc and the thread. And the sixth will be the tension and torsion coefficient of the spring. And the seventh will be the need to more describe on Reynolds number because I can not see the relationship between the Reynolds number and their external data. So this is my review. Thank you.
Concluding remark by the reporter.
So concluding remark for our experiment is, as for the possible parameter, the thickness of the paper, if applying the thickness, the air flow will possibly deviate from the opposite field when the thickness gained. And turbulence is the chaotic flow is what caused the data loss. And the condition when it comes to the ideal disk. The definition of the accuracy is when the loudness can correspond to an angle. And the qualification of definition of the delta theta. And if we modify the setup and consider the tube and try avoiding a possible reflection, maybe it could be more close to the ideal situation. And we will do more variables in future research. Thank you.
Okay. Now, please. turn for the juror to ask the questions. Any?
So from your for the reporter, from your theory, what's the relation between the delta theta and dB?
When the dB gains, the delta theta also gains.
Yes, but how you increase linearly or dB squared? You know,
Can
what's the relationship between delta theta and dB from your theory? Linear relationship or parabolic?
right square.
Square. And your data fit to your theory
Yes.
of the opinion of the opponent.
I also think that square. I also think it's true about what you said, where the
Question to the reporter of the street, and according to the reporter's results, you said that it seems that your data fit the theoretical curve. However, I want to make sure the theoretical curve is just a mathematical model or based on your science model. For example, you have a theoretical curve, and you should have already measured, for example, the K, the capital K. You mean related to the torque, but did you measure the K for the three different materials?
Yes, we changed the torque constant for each material.
And you measure the K.
Yes, by the sensor.
Okay, so I just want to make sure the so-called theoretical curve is based on your calculation, or just you use a square mathematical function to model the data, to fit the data. And then there are two kinds of theoretical curves. The first kind is you just guess is a square curve, and the second kind you calculate.
We calculate.
Do you think the model is correct or not?
Because I didn't really know the derivation in the curve line, so I can't really tell you that if it is right or not.
Although I think the setup has a lot of external factors, but you can see that the line and the data is fit, so I think that might be right.
Another question. Did you investigate the accuracy as a function of frequency?
No, we didn't measure the frequency one, but we observed that.
What's the result of your observation?
When it is like 60 times, when it's like 60, 120, 180, it will turn. It's kind of this kind of act like turbulence flow effect, so it will rotate this one.
What's your opinion? The accuracy as a function of frequency. Acoustic, right? Frequency is one major factor.
I think that I agree with the reporter.
Which is
About
what's your opinion?
So I want to know that the voice is louder and also it will be more accurate, so maybe
But nothing to do with frequency at all.
frequency, I think the main will be the amplitude of the sound. It's louder now.
So the scoring time. Starting from the reporter, 6, 8, 7, 6, 8, followed by the opponent, 6, 8, 6, 5, 7, and ending at the reviewer, 6, 8, 8, 7, 8. So have a short but relaxing lunch. Anything else? 就是可以解散了。